Have you ever had a hunch that two things are connected, even if they seem totally random? Well, a lot of the time, the proof is hiding right there in the data. Today, we're going to pull back the curtain and show you a really simple but super powerful way to find these hidden relationships. So let's dive in. We're going to start with a question you might hear in any school hallway. A class did a survey to see if there's a link between playing sports and playing an instrument. Think of us as detectives. Our job is to look at the clues, the data, and see what story it tells. Now, the official term for what we're looking for is an association. That's all it is, a relationship where two things seem to be connected. So if a student plays a sport, does that make them more or less likely to also play an instrument? That's the association we're trying to figure out.
All right, every good detective knows the first step is to organize your evidence. We can't work with just a jumble of survey answers. We need to get them into a structure that actually makes sense. And this is our main tool for the job, a two-way table. It's just a simple grid that organizes our two variables, sports and instruments. We've got some of the numbers filled in from the survey of 25 students, but as you can see, there are some blank spots. Our first mission is to fill in those gaps.
Filling this in is actually pretty straightforward. It's really just some simple addition and subtraction. Let's walk through it. First, look at that plays sport row. If the total is 16, and we know 5 of them play an instrument, well, 16 minus 5 is 11. That's how many don't. See? Once you have that, you can use the same logic to fill in all the other empty boxes. And there we go. All our clues are laid out nice and neat. We can see that 11 kids who play sports don't play an instrument, and 4 kids who don't play sports also don't play an instrument. But hang on a minute. Is that really a fair comparison?
This is such a critical point. The groups aren't the same size. We've got 16 students in one group, but only 9 in the other. Just comparing the raw numbers, 11 and 4, can be totally misleading. We need a way to compare them apples to apples.
So how do we create that apples-to-apples comparison? The answer is percentages. By turning our raw numbers into percentages, we can finally make a fair, direct comparison, and it doesn't matter how big or small the groups are. Now, in your stats class, you're going to hear a fancy term for this, relative frequency. Don't let the name fool you. It's just another way to say percentage. Think of it as a tool that gets all our data onto the same 1 to 100 scale so we can finally see what's really going on. Okay, so let's actually do the math for our first group. We want to find the percentage of sports-playing kids who don't play an instrument. That was 11 students out of a total of 16 in that group. So we just divide 11 by 16, which gives us this decimal, 0.6875. And to make that decimal a percentage, just move the decimal point 2 spots to the right and round it up. And there you have it, 69%. So 69% of the students who play a sport don't play an instrument. Now that's a number we can really use. So when we do that for the whole table, check this out. Now we get the full story. Among the kids who play sports, 69% don't play an instrument. But for the kids who don't play sports, that number's only 44%. Okay, now things are getting interesting. It really looks like there's an association here. Numbers are great, I love them, but sometimes a picture tells the story in a way that numbers just can't. So now we're going to take our table of percentages and turn it into a simple chart that'll make the association pop right off the screen. And here it is, a segmented bar graph. Each bar is one of our groups, right? Plays sport and does not play sport. And they're broken up by the percentages we just found. Just look at the blue parts, the kids who play an instrument. See how much bigger that blue chunk is for the no sports group? That visual difference, that's the association. You can see it instantly. This visual makes our conclusion super clear. Based on this survey, there seems to be an association. Students who don't play sports appear more likely to also play an instrument. Now, here's something that is absolutely crucial to remember. Association is not causation. We can't say that not playing sports causes someone to pick up a guitar. We can only say that in our data, the two things seem to be linked. All right, you've got the method down now. Table, percentages, graph. So let's run through another case to lock in the skill. Imagine you're a factory manager and you've got a bunch of bad erasers coming off the line. You need to figure out which machine is causing the problem. This time, let's just jump right to the visual evidence. This bar chart shows the percentage of flawed erasers coming from each machine, which are color-coded. What immediately jumps out at you? I mean, look at the yellow and green bars compared to red and blue. It's not even close.
Yup, with just one look at the chart, the answer is obvious. The flawed erasers are strongly associated with the yellow and green machines. The manager now knows exactly where to look to fix the problem. That is the power of seeing your data the right way. So let's just do a quick wrap-up of the 3 main tools we used to uncover these hidden patterns. These are the big ideas you'll want to take with you.
First, we had the two-way table. That's for organizing your raw data. Second, relative frequency, or just, percentages. That's the secret to making fair comparisons. And third, the segmented bar graph. That's what turns your numbers into a picture, so you can spot the association instantly. Just always remember that an association isn't the same thing as causation. So you now have a complete toolkit to go out and look for these patterns yourself. From the news you read to just things you notice in your daily life, data is literally everywhere. So the only real question is, what hidden patterns are you going to discover next?